The population of frogs in a small lake tripled in the last 30 months. If the population growth follows exponential law, determine the relative growth rate, and we can let time be measured in months. All right, so we're looking for the relative growth rate, which means we're trying to find the R value. And since we're saying, or I should say we're given, that the population's following exponential law, then we know that our general model will be A is equal to A sub 0 times E raised to the R times T power. So as always, I like to look at these problems numerically and organize what I've been given in a table. So we have our time, and it says that we're going to let time be measured in months. So T is going to be the number of months. And then the A value is our population. In this case, it's the number of frogs. So we're comparing T, number of months, and A, number of frogs. So it says that the population of frogs in the lake has tripled in the last 30 months. But it doesn't tell me how many frogs we began with. And that's what makes this problem a little bit more unique. So at a time of 0, we don't know how many frogs we have. So looking at our general model over here, we always use A sub 0 to represent the initial number of frogs. So we're going to just have to leave this generic for right now and just say at time 0, the number of frogs is denoted by A sub 0. But then we know that in 30 months, so 30 months, that's a time value. So when T is 30, my population has tripled. So that means I'm going to have 3 times the amount that I began with. We could write that as 3 times A sub 0. So if you want to just think about numbers for just a second and throw in some fictitious numbers so you can make sure that my notation makes sense to you. Say you began with 5 frogs. Well, then if it's tripled, we would take 5 times 3 and we'd end up here with 15 frogs. Okay, if you had began with 100 frogs and my population triples, now I have 300 frogs. So whatever I'm starting with, I'm multiplying it by 3, and since I don't know how many I've started with, I'm just calling it A sub 0. Now I'm going to have 3 times A sub 0, 3 times the initial amount. And what this allows us to do, even though we don't have a value for A sub 0, it's going to give us right here this nice ordered pair that we can still substitute in to my equation, which is going to allow us to solve. So look what happens. My A value is 3 times A sub 0 is equal to, I still don't know my initial amount, A sub 0, E raised to the R times, and my T value here is 30. So I'm just substituting in T is equal to 30, and when T is equal to 30, we know we have 3 times A sub 0. So solving this little exponential equation, we'll begin by dividing by my initial amount, A sub 0. And notice what happens here. When we divide by the initial amount, the A sub 0's divide out on the left as well. So now we're left with 3 is equal to E raised to the R times 30. So incidentally, if I go back to my table, and let's say I went back to one of my little fictitious numbers here, let's say I thought, well, maybe there were 5 frogs initially, and then the population triples, so if you had put 15, look what would happen. You would have had 15, oops, excuse me. There we go. You would have had 15 is equal to my initial amount, which I had said, let's call it 5, is equal to, or 5 times, I'm sorry, E raised to the R times 30 power. And your first step would have been to divide both sides by 5. My point being, you would still get 3 is equal to E raised to the R times 30. So it doesn't actually matter how many frogs you are beginning with. You don't have to know that information. It doesn't matter. We're still going to be able to solve for R because if the population triples, then you're always going to be left with a 3 here on the left-hand side. Going back to what I had though, A sub 0 and 3 times A sub 0. So just finished solving this equation. We rewrite it in log form. Right now my base is E, so rewritten that's going to be log base E of 3 is equal to 30 times R, which of course is the same as the natural log of 3. And so my R value will just be the natural log of 3 divided by 30, which if you put that in your calculator is approximately 0.0366. So multiplying by 100, or moving your decimal 2 places to the right, will get our percentage, which is about 3.66%. And there's my relative growth rate.